We're live talking about turbo Civics tonight. I have the thumbnail up, and that actually is a single cam D series Honda. That one was a Civic Si, I think. We ran a test for the guys at CX Racing long ago with one of their kits, put their kit on a Civic that they happened to have. And so we ran it with one of their inexpensive, kind of a complete turbo kit. So by complete, I mean it had the exhaust manifold, the dedicated turbo exhaust manifold, which in this case actually was not too bad. I mean, it positioned the turbo so that the opening was behind the radiator, which is not ideal, but running a tube to get like cold air into it, maybe from the fender well or somewhere. The other thing that happens a lot of times, and Civic guys will know this, but if you have a Civic and you don't have AC in it, which guys that have turbos a lot of times don't have that in there, or will take it out so that there's room for that. But there are some turbo kits that actually fit with AC. And I'm actually a big fan of having all of that, because why not have it all if you can? But in this case, there is none, and you have a big opening in front of the turbo. So you got a lot of cold air. You know, you'd want it going through the radiator so that it will cool everything off, but it's also going into the area where the turbo is. So hopefully you're not just getting hot air, that you're also getting cold air. But the turbo manifold, the exhaust manifold, cast iron, so it's heavy duty. The other thing I like about it, the turbo bolts right to the bottom side of it. The shape is nice. It's got relatively good runners in it. They're not all even, but from a turbo manifold, it's really hard to kind of expect that. But those are pretty good. The other thing I liked about it is it seemed to offer pretty good boost control, even with what I would call maybe a questionable wastegate, although this one worked good. So, and we were just running a manual controller to it, but it was a 2-bolt flange, like an old school tile kind of deal, and it worked fine. That's how the provision for the wastegate was set up on the exhaust manifold, cast in. This was a casting. It was done really, I thought done fairly nicely. All the kit went in there, it bolted on, it fit pretty nice. The downpipe was good. This kit came with a blow-off valve. It came with the tubing. It came with a front-mounted air-to-air intercooler. Naturally, it didn't come with any sort of tuning, so it didn't have injectors or an FMU or a pump or anything like that. But this, that's something that we took care of. And then this particular Civic was tuned using, I think that Ernie used chrome on this thing. And the cool thing about it is these motors will make near 100 horsepower at the tire when they're stock, and then and you could get them to make a bit more than that, but we easily got it to 200 at very low boost, and then just as easily got it well over 300. Although I say that was easy. In this particular Civic, there were a few things that we had to do. We had to, the clutch that was in it was maybe stock. If it wasn't stock, it was, I don't know, stage 1, whatever those kinds of whatever those clutches are. But it was not enough for the kind of power. Once we got the thing where it was making, 300 horsepower, let's see where we were at in terms of Honda. Yeah, so actually 325 horsepower and probably 278 foot-pounds. So at that level, there was just no way that this thing was going to be able to handle that. And for those guys that are interested, that was about 20 pounds of boost, right at 20, 19.9 to 20 pounds, but only at the power peak that was at 6450. So, a pretty fair amount of boost, but to get it up into the 320 horsepower range, it definitely required that. But like I said, the cool thing is that in this particular instance, this turbo kit was not an expensive deal. It was a complete deal from the guys at CX Racing. It went on. In fact, the most expensive part about it probably was the other things that we had to do it. Now, naturally, this thing had to have bigger injectors in it, because stock injectors just don't flow anywhere near enough. They're designed for 100 to 120 horsepower combinations. Now, they leave you a little bit of leeway on factory injectors, and then you could raise the fuel pressure to get a little bit more. But realistically, if you're trying to double the power output, you're going to need to have more than that. So bigger injectors. It also needs more fuel pump. Lucky we're talking about 300 horsepower at the tire, so you're not talking about a ton of power. So there's lots and lots of pumps that will support that. I think we probably put a Walboro 255 or something in it. But the interesting thing is that we did, and I think we ended up putting a camshaft in this thing too. We ended up testing a Crower cam probably in it, I think is what we ended up trying in it. And that worked. We changed the springs and put a camshaft in it. It definitely made more power. It made more power at a lower level of boost too. So it worked out really good. But the thing is, the things that surprised me the most were how well the wastegate worked. This is one of those instances where I normally recommend a good wastegate, and I recommend guys spending money on that to have boost control, especially when you're looking at something like this. This particular wastegate seemed to work fairly well. It did have a slightly rising curve. I don't know exactly what spring was in this thing. I think that the lowest boost that we saw was about 9.5 or 10 pounds. I think that they told us that it was a 7-pound kit or a 7-pound wastegate, but it was not. So it was more than that. And changing the downpipe from the turbo exhaust has a decided effect on what's happening with the turbo. Obviously, it really, really likes having a free-flowing exhaust. When you're trying to flow into the stock exhaust, the stock Honda exhaust, the factory exhaust, with a cat and a muffler and the stock tubing diameter, not nearly as good as if you just put a 3-inch section of exhaust on it. It likes that a lot. Of course, that's very, very loud, and that's off-road kind of thing, only for a vehicle that you would be running. But for a drag race application, you certainly could do that, and it will definitely make more power. In fact, we probably I don't even remember what size turbo this was that they had with their kit. I'm thinking it was a GT30 76 or probably something similar to that. I'm thinking it was a 350 or 400 horsepower turbo is the way that they had advertised this particular kit. But like I said, the nice thing, it all went on. And then the key to the success of buying this stuff that was fairly inexpensive, and all the turbo stuff at least worked fairly well. All the clamps went on, and there was no leaks or anything like that. As I said, the wastegate worked. The turbo spooled up fairly nicely on this combination, despite the fact that it allowed us to basically triple the horsepower. We went a good bit over 300 horsepower at the tire with this combination. Yet the boost response was still, I would certainly be happy with driving that thing around with that kind of response, the kind that we were showing on the chassis dyno. It worked out fairly well. It didn't have peak boost till the top of the RPM range, but guys that are driving Hondas are used to their power being at the top of the RPM range anyway. I mean, let's be realistic. So it's a good combination, but the key to the success of that is not the exhaust manifold or the turbo size. It could be the wastegate, although in this case the wastegate worked very well, but it's the other things. We did the things that we were supposed to do. We put good fuel in it because we knew that we were going to be running the boost up, and we were running 20 pounds. We put good gas in it. It had a front-mounted air-to-air. We just put a big fan in front of it, but it had proper tuning. We had chrome on it, so anything that will allow you to put the right air fuel and the right timing in it, if you can do that, then you can make good power, and you can do it safely. This motor was taken apart, and they did put ring gap in it before. I mean, we ran 7 or 8 pounds or whatever initially with the kit, and then decided, hey, look, we're gonna turn this up because the guys from CX Racing at the time wanted us to go, well, how far will this go? We're like, well, if we're going to go there, it's going to need a couple of things. It's going to need bigger injectors. It's going to need more fuel pump. It's going to need head studs and a gasket. And while we're there, we need to take the pistons out, and we need to do ring gap in it. Because if you're not going to do that, you are definitely going to break a piston, not because the piston is not strong, but because you're going to pinch a ring and you're going to break a ringland. So we did all that to make sure that it was right. And then it was tuned properly. It had big enough injectors, had a big enough pump, and good gas in it. And with all of that stuff, once you do that, then good things can happen. And then you run into things like we did. You run into things like the clutch. Not uncommon on a stick car with with superchargers. You run into belt slip sometimes. With a stick car, with the automatics, you run into converter, choosing the converter for the camshaft and stuff. But with stick cars, sometimes it's clutch, especially if you're trying to get away with the stock clutch stuff, which the stock clutch designed for stock power output plus a little bit more, but not 50% or 100% or 200%. They don't size the clutch and the clamping force to do that because people don't want to drive a clutch like that. They don't want to have a clutch that's really stiff and takes a daily, every day's leg day basically with those kinds of clutches. So you don't want to do that. So, you run into the problem. But the only thing that allowed us to get to the point where we needed a clutch was because we did all the other things right. It was tuned properly. It had good gas in it. It had the right size fuel pump. It had all that stuff. So you should just know going in, rather than trying to, I wonder what I can get away with. Well, on a stock fuel pump, not very much, especially if you're jacking the pressure up. How much will the stock injectors work? They won't. You shouldn't try to do that. That shouldn't be your goal. Your goal should be to put injectors in it and put a pump in it, because it's going to need both of those things. Then it's also going to need a tune. I've seen lots and lots of guys, and the Honda guys aren't the only guys that do this. Mustang guys and Camaro guys and Dodge guys, everybody does it. In every group of performance enthusiasts, there are those guys that will just put this turbo on and take it out. Wow, got to feel the boost. Yeah, that's great. It's all wrong. You don't know what the timing is. You don't know what the air fuel is. You just know that it has boost. That's a really, really good way to break it. So you shouldn't be doing that. And yet, time and time again, and no matter how much I tell you not to do it, guys will go out and do that. And those are the guys that are fixing their motor, or those are the guys that are complaining about how bad turbos are. Turbos are terrible. Or Honda D series Civic motors are terrible because they just blow up. Yeah, they do when you run lots of boost and you have stock timing in it and you detonate them. Then they definitely do blow up. Otherwise, they do not. And as we showed here, they can make good power, and this one ran a long time. We went for some lots and lots of dyno runs on this thing, so it did very well. So the moral of the story is, even though I recommend more often than not, almost always, get a good wastegate, sometimes they work. I recommend getting head studs. Lots of guys don't do it. I do recommend getting ring gap. Sometimes guys don't do that. Sometimes I don't do that at low boost. I almost always do it at high boost. But that can work. The thing is, when it doesn't, and I take full responsibility when it doesn't, when you do that and then it doesn't work, then you got to go, okay, that's on me. That's not on somebody else. But the guy in the forum said I could do it. No, that's on you. If you decided that I'm going to run this anyway and see how far I could take it on stock ring gap, or heaven forbid on stock injectors or stock fuel pump or whatever, I'm going to see how far I can go. Or I want to put this in there without a tune. Okay. That sounds like a solid plan. And then right after you blow it up on your first pass, that you let us know, and we'll be able to talk to you and tell you, what the reality is and why you shouldn't have done that. But that's all part of it. So let's see. We'll have a poll tonight. So with that in mind, have you ever gone into boost, taken your thing out and gone into boost without tuning it, without knowing what the airfill and timing are? Everybody be honest. So let's see what you guys got going on tonight. Boss 260. Oh, 260, not even 290. Nice. LS swap. Robert, you guys are getting snow? Boss 260 KW Falcon. Sorry if this has already been asked. I just joined. Jeremy, there's no bad questions. Can you boost an F-type Honda engine without a ton of supporting mods, preferably small single? What other supporting mods are you talking about? We just talked about them. You will need injectors. You will need a pump, because if you're going to add a turbo, you're going to need to have fuel flow to make that happen. You can run a turbo with stock head gaskets and head bolts and stuff, and you can run low boost, maybe without changing ring gap. Although I blew my B series up when we finally heard it, we heard it because it didn't have enough ring gap. So like I said, if you do that, which people have and you can, but when you heard it, then that's on you. Do you think it's possible to spool a GT45 with a low compression D16 with a built head? Yeah, eventually. So if you had even if it's low compression, if you have lots of camshaft in it, a ported head, and the thing wants to run the 7500, you'll eventually get that spooled up. But there's no reason to have that. That'd be a terrible turbo for that. It's way too big for a D16, unless, like I said, are you trying to make 600 or 700 horsepower with it? And probably a better choice would be a GT35. If it goes vroom or boom. Okay, let's see. We're going to go from top chat to live chat. It's live. It's all the way live. Let's see. Not a fan of harmonically unbalanced engines. But all things being equal, inherently balanced engines are the most durable. I didn't understand the logic there. The mini motors are total. First, take one apart. Well, after a lifetime working on V8s, it was new to me. Eric, you still got your Honda Z50A? Nice. What's a good junkyard turbo to get for a J30 to get 350? Go get one of the diesel turbos from a Power Stroke or something. Or you could get maybe a pair of if you can find the little Ford T3 turbos or Saabs, or maybe even two of the, well, you're not going to find the Chrysler stuff probably. And I think the Volkswagen stuff is going to be too small. Maybe the Ecotech ones or the EcoBoost ones. Have you tried max speeding rods? I have not. I've tried their turbos. Yeah, I've tried their turbos. I've run their GT3582 turbos. Running max speeding turbo been a year. Good. Can you convert a carb to a blow through? I've never tried it. Motor Trend has an article $60 versus $1,000 for a carb. Yeah, the blow through carbs are not cheap. Maybe I'll talk to Brule about that and see if we can come up with something. Had a 95 hatchback. I had one of those too. Some cam turbo for life. A D15 with an HF manifold and a 14V turbo and a Vtec FMU. I've been down the Vtec FMU trail many times. So happy to see you cover this. I have a 500 horsepower small block 71 Dart, but daily a 700 horsepower 98 B18 Civic. 700 horsepower is serious power. Just go K24. Yep, that works too. They work. But like I said, everybody seems to immediately be offended by when you tell somebody, "Hey, look, I ran my VX turbo. I didn't do a turbo. My VX Honda Civic, the high mileage deal. I wanted to put a turbo on that. Oh, well, why wouldn't you just put a B series or a K series or even a D series? 1.6 D series single cam." Because making power isn't the goal, isn't the only goal. What I want is the VX and 55 miles per gallon, which I was getting driving on the freeway. But I would also want another 50% of power, a 50% increase in power, should I choose to use that instead of getting good mileage. I want both of those options. I don't want to make 1,000 horsepower or 500 or even 250. This thing would have been great with 120 or 150 at the tire. It would have been awesome. Plus the lean burn stuff would have been awesome. Same thing with a 2J or an RB or a rotary or whatever the thing is that you're doing. It's what you have. Make that better. The guys that are arguing that, oh, you got to put an LS in it, that's just silly. There's nobody that's a bigger fan of LS motors than me. But my like for them doesn't stop likes for other stuff. There's lots and lots of cool stuff out there. Car peeps. Thinking about going D-Series turbo and pulling my B16 out for a refresh. You can make good power and it's still fun. And if you should have something in there while you're rebuilding the other motor. They're fun drivers. I loved having even a 7-pound turbo on my 2-liter Vtec Focus. It made the thing so much fun. And then 10 pounds was even funner. So, have you ever went into boost without tuning the combo? 42% are not lying. I voted yes because the car came with the turbo. I didn't have to tune it. I was working on my turbo mounting flange. Is there gains on porting the hot side of a GT45? No, I don't think so. I did that with nitrous on a stock piston small block Mopar. 140 worked fine for 3 years. Turned it up to 150. Lasted 3 passes. Number 8 piston. Just learned about Ken Block. Yeah, that's unfortunate, man. That's a bummer. Perfectly capable of doing the injectors and pump, etc. I've not experienced the ring gap. I wasn't the first time I did in my VX. Third gear was notchy, making noise, and so I had never taken apart one of those transmissions before. But you just go to YouTube and go, oh, that comes off, and then you slide that lever over, and you move that thing, and it comes apart, and then you just take that gear out, put the other gear in, and put it all back together, and make sure you seal it with Honda Bond, and boom, you're in business. It's literally that easy. And after you take it apart, the nice thing now is we all have phones that have cameras in them. You take pictures or video of every step that you make, and then when you go back to put it back together, you're like, how did that one go on there? Oh, lucky for me, I took pictures, and now I know where all the dowels go. I know how the head gasket goes. I know how to put all that back on. And then make sure that you mark the caps so that you don't take them all out. That's one thing I would recommend. My pro tip for you would be to do one piston at a time. Don't take them all out. Don't take all of them out. Don't take all the caps off, and then take all the pistons out. Do them one at a time. Take one out. Look at the way that the cap goes. When you have it in there, mark the side so that they stay together. So that the cap, because that's the only thing that you have to be concerned with when you're taking a piston out. You take the head off. You take the piston out. You take the cap off. You push the piston out, and then take the rings off gently. Don't break them, and then you measure them, see where they are, and then cut them and put them back on. And when you put it back in, know that it goes the same way. Usually a piston will have either valve release, which go the high side or the low side of however you're looking at the block. Sometimes they have little indentations that mark the forward part of the piston toward the front of the motor. However that is, take a picture so you know how it goes back in. When it goes back in, the cap that you marked on both sides, on the big end, on the rod side and on the cap side, this one has a 1, this one has a 1. They go together just like that. The bearings go back together. You tighten it up. It's not rocket science. Richard, have you seen the new Blueprint 4-cylinder? I did see. I've seen many pictures of it. I haven't obviously seen it in use or anything. Which tuning solution do you recommend? I always use on the a picture of on this one we used Honda. It worked good. That was a Bonneville car. And on the D series that we used, they had chrome on that one. Anything that allows you to, and I've also used, I think we used fast on the engine dyno also on the B series stuff that I ran on the engine dyno. But anything that allows you to put the right timing, the right fuel in, that's all good. The VWs use pretty small turbos. They do. I remember looking at one. I remember walking into my first VW place. A buddy of mine had a 1.8T Golf, and we went into, I I forgot the name of it. It's here in it was in Southern California. It was a turbo place for Volkswagens. And we went in and we're looking, I'm like, man, that's the smallest turbo I've ever seen. He goes, oh no, that's the upgraded turbo. The smallest one you've ever seen would be the factory one. And then I'm like, well, yeah, but it's small, but it's not Chevy Sprint turbo small. I like to do some hot lean burn turbo 4-cylinder stuff. Yeah, I just wanted boost on the, when you went into boost, it wouldn't be lean burn anymore, obviously. I would just, it would have, fuel enrichment and all the things that it needed. And when you're going into boost, you're not trying to get good mileage because you're trying to make power. Those are different things. But while you're cruising, there's no reason it can't cruise down the freeway at 65 miles an hour and get 50 plus miles per gallon. It can certainly do that. And it can do that with a turbo or without a turbo. That would be the nice thing. Turned up my KO3 turbo Audi A4, 2-point slow to 16 pounds. Watch the boost gauge fall off past 4,500. Yeah, a lot of the factory stuff have falling boost curves. That's pretty typical. Yeah, the Honda stuff worked good. When are we going to get a 7.3 IDI turbo Big Bang? Yeah, probably not that. $15 degrees timing on 91 octane with 12 pounds. Made the tune safe. I taken a stock turbo off, thrown a bigger one on. A stock ECO kept up till 10 pounds and then wasn't happy. Yeah, again, if the turbo can flow a lot more air and make more boost and you can make more power, you have to have the fuel and you have to have generally less timing when you do that. If I was looking for an old Chrysler Slant 6, which vehicles do you think are the most found in? Doing math now for production and models to look for most likely they don't get to the yard too often. I have seen Slant 6s in the yards before. Most of the ones that I've seen are in trucks, but they also came in the passenger cars too. Apparently you can convert a basic double pumper Holly for $60 worth of parts and cutting the choke off. Do you even need to cut the choke off? I mean, milling the choke horn was always a airflow performance thing, but I have an MS3. I should be able to make that work on the D16 with the distributor. Yep. For a single turbo GT45 on a 5.3 LM7, would a single wastegate be good or two? You won't need two for that. Just one that's big enough, a single one that's big enough. Crank up a 1.4 turbo cruise. I was talking to Oliver about that. I thought that was it a 1.4? I can't remember now. Can't remember if it was an Ecotec or an EcoBoost. I'm gonna have to ask him first. But he was not too happy with it. I do have a Slant 6 that I'm gonna put back together and we'll do some runs with. I need to give it a Dulcich paint job though. I just acquired a Rec 98 Accord F23A1. I'm going to rebuild for my son and put a 97 Accord that has an F22B2. Richard, did you get a chance to check out the 3-valve? I have looked at those before, but for some reason I wasn't thinking it was an M90. But having a bigger motor is a good idea. I just don't. How fast they're spinning them is kind of amazing. If you add ring gap to a car that was turbo from the factory, can you run more boost than you normally would on a stock ring gap? Yes. Yes, you can, assuming that you have the right air fuel and timing also. My brother put a bigger turbo on his 1.4 Cruise, and he doesn't like it so far. That's not uncommon. The factory stuff is they get used to the thing being so responsive, because in the factory, that's their concern, is they want the little motor to feel like a bigger motor, especially for the American market, the people that are used to big V8s. So they want things to feel torquey, basically. And that's what they look for in these things, in little turbo motors, is to get boost response. I mean, they're looking at, peak torque at 1800 RPM or something. They want the thing to feel like a much bigger motor than it is. And the problem is, when you go to a bigger turbo, because you're looking for more power, it's like the camshaft thing. You can get more power with a bigger cam, but the trade is it's going to be less down here. And the same thing with bigger turbos. I've heard that later slant sixes are the ones you want for performance. Something about a lighter crank. '92 4.3 liter 6-cylinder turbo size ideas. Probably a GT35 82 would be good for that 4.3 liter. That's like a 500 to 600 horsepower turbo. And so depending on what you're doing with it, NA, that should be right in the wheelhouse, and things should be fairly responsive with that. Larry, you're streaming 24/7 on 3 systems now? That's the way to do it, man. That's how he rolls. Let's see how our poll is doing. Have you ever went into boost without tuning it? 40% saying yes, and 60% are saying nah. Hard pass on that. It's not good. It's not a good idea. Razor blade rebuild, add gap. There you go. That said, I'd probably pick a GT30 or the GT35 for the 4.3. Yeah, I think it would be a better choice. And certainly start with that. If you go, hey, look, this thing's all kinds of responsive, but now I really want more power. So if you put it together so that you have a cam and a ported head and some kind of, maybe the marine intake manifold or something where you're making decent power, and then you really want to wick it up, you could always step up in turbo size. 28 to 30 ring gap for all turbo engines? No, it's based on the bore size. So 6.5, 7 thousandths per inch of bore is what the formula is. Erotters. Let's see. What did you have him build? I'm scrolling. Keep them doggies scrolling. I'm not seeing it. Richard, you don't see the logic in having balanced primary and secondary rotation and reciprocal planes as advantageous in reliability. So give me specific examples of the motors you're talking about that you think are more reliable based on their balance. Richard, is it better to put the wastegate on the manifold near the turbo or the crossover pipe? I don't know what you mean by better. They all work as long as the wastegate can open and get rid of some of the exhaust energy. It will work. It can be near the turbo. It can be far away from the turbo. It all works. Ran GT35 for years on my SRT4. It's a great midway turbo. And with more displacement, it would be kicking in a lot sooner. I agree. It is a good size turbo for, I mean, it's a solid 500 or 600 horsepower turbo. Wouldn't the converter change also help with enjoying the bigger turbo? It would. The gearing in the trans, the gearing in the rear end, if you have a converter, all of that stuff will help, just like it does with the camshaft. If you could get the engine up into the RPM range past the questionable area where it lost power, or up into an area where it's starting to make power, then it's just going to feel better. So if you can do that with, torque multiplication, that works too. Richard, remember the intake runners like long tube headers. So if you look out there in the world, there are intake manifolds that look like headers. The OEMs have already done that. So that doesn't matter that they look like that. All that matters is that you have air going into some kind of common plenum, and then you have runners going in. And then the length of the runner is going to dictate what happens. The fact that it looks like a header or looks more like a conventional intake manifold is not going to change that. With superchargers, is there a difference between the one that mounts on the top of the intake manifold or one that mounts on a bracket with the accessories? Those are different kinds of superchargers. So they're going to provide different boost curves. So if you take a look at the video that I have up where I tested a Vtec supercharger, which is the accessory mounted, front mounted one, and then a roots blower and twin screw blower where those are mounted like in the middle of the V, in the valley of the V. It's not where they're mounted. It's just the design of the supercharger is quite a bit different. A centrifugal blower has a rising boost curve, and the positive displacement blowers like the roots blower, like a Eaton, or factory blowers or twin screws tend to have more immediate boost, but be less efficient at higher engine speeds. So again, there's always a trade-off. Did it? If you have the story already, can't you go by the story and try to do it? An inherently balanced engine would be better in theory, but in practice, there are many other variables that can affect longevity. That was going to be my point, is that would be one thing you could look at, and you could also look at lots of other things like oil change and tune, and there's a lot of other things that would affect reliability long before the inherent balance equation would ever come into play. Have you tested superchargers with bypass and or clutches? We run almost all the superchargers we run have certainly the positive displacement ones have bypasses on them, but the bypass only comes into play after you get off the throttle and when you're running under cruise. But I've never done one that has a clutch hub so that it engages and disengages. I've never done that, but if it did and you could make that happen, it would just be on and off kind of thing. 61% saying no, they have not gone into boost. But the bypass stuff, almost all of the factory blowers have that, and almost all of the aftermarket positive displacement stuff. And then like a Vtec and turbos and stuff, sometimes they don't have bypass valves. Sometimes they have blow-off valves, depending on, and that's going to be a function more of how their management is done. If they have a mass air meter or a vane meter, they have to reroute it back in. If they don't, they just blow it to atmosphere. Balance doesn't matter at all. No, we should all be very well balanced. That's very important. Have you caught the video from Two Dogs Garage about you and LSA? Is it an LSA supercharger? Because I don't really know what they would talk about there, or if they would talk about, is it lobe separation angle? Is it like camshaft? I'm hoping that it's every cam is a turbo cam, because that's always good when people complain about that. Didn't Mercedes use an electric clutch? I thought somebody told me that they did. Richard, what's your personal method for cleaning deck surfaces from MLS residue? I do a razor blade rebuild, so we would scratch it up with not scratch it, but we would scrape everything off with a razor blade and then blow it off with an air nozzle if it's a junkyard style motor. Sometimes we can take, I put oil on very, very fine sandpaper or even Scotch-Brite, and we'll run that over it also just to kind of clean it a little bit. If you had your choice, Mopar 340 engine or Mopar 360 Magnum, I would pick a 340 only because I would then resell the block because it's worth about $1 million compared to a 360 Magnum, which you could go find everywhere. Vtec works. It has basically 2 cam profiles, and what they do is it has 3 rockers. So it has rockers like this. Wah, wah, wah. So normally the outside ones are working and they're pushing down the valves. You know, it's running on the camshaft, pushing down the valve. Then there's a big lobe in the middle here. And what happens is a pin slides through and locks these 2 out of the way. And now it's only working on the middle one, and the middle one has the big cam. And so it pushes a little plunger over, it locks it out of the way. And so it runs on the small cam or runs on the big cam. And it all does that with oil pressure pushing a plunger over. And it has a little, and it's just easy. It's a solenoid operated deal. Vtec solenoid. Superchargers with bypass valves used. Yeah, it reduces, it improves cruise fuel mileage if you have a bypass on a supercharger. Yes, it was about lobe separation angle and how critically important it is versus some important person you had on as a guest saying that it didn't matter at all. I haven't seen it. I've never had anybody on my, I've never done an interview that I can remember on my channel. The only guy I've talked to is Mark Sanchez, and he wouldn't have been talking about something like that. I'm the only one that ever says that it's and I would stand by my statement and talk to anybody about that in this industry, because they won't have the they won't have the ammunition that I have. And so I'll sit and argue with anybody about that. Not argue, discuss. So whoever it is, from any cam manufacturer, any cam expert, any turbo expert, anybody that wants to sit down and have that discussion with me about every cam being a turbo cam, I am happy to oblige that, because I guarantee you that one guy will come out on top of that discussion. Richard, I think he means cattle dog garage and the visor had 128 cam LSA for lobe separation angle, not LSA blower. Okay. And David's visors, his cam formula is not a universal thing. I've talked to David about this many times. The 128 cam thing is not, David doesn't do LS cams. This 128 cam formula is not designed for every engine family. He's already told me that. It's a really good idea and it really helps. But the problem is, as I've gone over many, many times, it does not take into account all of the reasons that people buy camshafts. It's people buy camshafts just because of the way they sound. People buy them because they're on sale. People buy them because they have a cool name. People buy them because they'll work with a stock converter. And all of that, none of those have anything to do with some formula that will give you some sort of optimized power production, because that's not the only reason that people buy cams. That video is talking about lobe separation angle. He used some screenshots of your dyno tests. I like how people try to take my stuff and use it for their own nefarious deeds. Toyota Starlet intake manifold looks like an exhaust header, common plenum connected to 4 long runners. Some autocross guys running Tercels would slap that manifold on a JDM. Oh, I was talking about Brian Tooley saying about LSA. I talked to Brian many times about this. Many, many times. Have you tested the difference between intercooler circulation speeds on the dyno? How much does it affect sustained power and recovery? So are you wanting intercooler flow rates? Because we don't have recovery, because we have 2,500 gallons of water available to us for an air to water intercooler. So there's no recovery. It has more flow than we could ever use. So it's not in a sealed system. In a sealed system on the street, that would be important. And so we have a pretty good, efficient air to water intercooler, and you would have, recovery. You would have recovery needed for both an air to air and an air to water. I prefer the 360, but people have been pushing the 340s. I don't see a 360 would be the motor that I would build to I mean, a 360 will make more power than a 340. I'm sorry for all the 340 guys out there, but a 360 is 20 more than a 340. So if you did all the things the same, the one that's bigger is going to make more power as an absolute thing. The 340s I know were legendary and they beat up on every big block, and I've heard all the stories. That's fine. There's nobody saying that a 1968 340 4-speed car wasn't a cool car. It was, and it made good power. But imagine that 340 now with 20 more cubic inches and hopefully more head flow. Why haven't more manufacturers put Vtec in their cars? Love to hear a Vtec V8. Well, first of all, they'd have to pay Honda a licensing fee because Honda owns the patent for that. So when does Vtec kick in? It depends on the application. On my VX, it kicked in very early because it wasn't a performance VX. It was under cruise mode, which induced swirl to create mixture motion so that we could run very, very lean mixtures like 19:1. And then it would just go into, oh, now I'm operating with mild cam timing in normal 4-valve mode. Before that, it wasn't doing that. Other VTEC stuff can come in like on a B series Honda 5200 or something, somewhere around there. Has anyone ever tried to use a centrifugal clutch on a root style blower? I imagine somebody has, but I haven't ever seen it. Richard, what intake would you recommend for an 0953 daily driver truck? Have a truck Norris cam? You probably already have the intake manifold on there that I would recommend. You already have the truck manifold. If it's an 09, do you have the later style, like a Trailblazer SS style? Richard, have you seen the new Cadillac intake? It looks like a short tunnel ram with long runners that are C-shaped. No, I haven't. I have seen the 4-cylinder LS motor. Maybe test a Steve Morris turbo cam for $895 and see if it makes more power in the shootout. In what shootout are you talking about? And also the Steve Morris cam is Steve Morris is a really sharp guy. He really knows how to make power. But whatever cam he chose for a turbo cam, it's still just a cam. So if he chose a turbo cam that's a 231, 248 cam, that's going to be a different cam than a 206, 212 cam. It doesn't matter whose name is on it. Those two cams will do different things. They will make power in different RPM ranges. So I don't know what the specs are on his cam, but like I said, cams are cams, and there's not a magic one out there that's better than everything else. A little cam, like a factory cam, a 191 cam, is going to make less power than a 210 cam, and less than a 220, and less than a 230. That's how camshafts work. And people that tell you that that's not the case haven't done enough cam testing. And usually, depending on how far away you go in steps, there becomes a point where you have a trade-off. You're making more power, and then now you're losing power down low to gain the power that you have up top. That's what typically happens. And then on a turbo combination, it still does that, because it's what people don't realize is the turbo cam is just a cam before you add the turbo. If you ran it without the turbo, what would it be? It's not a turbo cam anymore because there's no turbo on it. But it's doing something NA. And whatever it's doing NA, when you add boost to it, it's going to be doing more of that. Bear, 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 bear. I've literally never ever selected a cam for all the quote right reasons that have been chosen for the sound at idle. Yet I was talking about it all the time. We talk about these idle clip videos that people do, and it's huge. I mean, I get asked that all the time. Well, did you do an idle clip? I'm like, what do you mean? They're like, yeah, we want to just hear the cam. Like, you don't care about a dynograph? You don't care about how much power it makes? No, I just want to hear it. How's it sound? Does it sound good? Okay. That's actually a real thing. And people decide that they want that, which is why Comp came out with their Mother Thumper deals. It's not because they make lots of power. It's because people want that 3/4 race cam sound. VVT is greater than Vtec. Not even. Those two are not even on the same scale. Vtec is actually 2 cams, and VVT is just swinging a cam. Minor gains VVT, big gains Vtec. And then when you have all of that, that's better. Turbo sensor, if you're a 182, 170, if that's a 50 number, that's a really tight, those are really tiny camshafts. First thing I do for me is I wouldn't have the exhaust be smaller than the intake. I'd have the intake be I'd have the exhaust be bigger than the intake. Also, I'd have, to give you an idea, a typical, like a Type R Honda B series cam is 220 degrees. So you're a long ways away from that. 220 at 50. And I'm sure that your thing flows, your head probably flows up to 500 lift, I would imagine. Now, you probably have to do some things to get it there. You might have to do porting on it. You definitely have to do some things with the springs. I don't know what the lift is because I don't know how. I'd have to look and see how the cams are, if they're going to swing around and hit anything, if they're going to roll off of the, I don't know if it's a bucket or I don't know what that motor is. I'd have to look at it to see. What about the cams that deleted Vtec? The guys that were running only very high RPM stuff and don't care about low speed power, and we're getting rid of that, because if you get rid of the Vtec stuff, usually you can run more engine speed, because the having a 3-lobe deal is, there's a lot of weight there. I don't like to run a lot of RPM in the Bonneville car. We only run 86 or 8,700, but that's why they're doing it, because they're trying to run 9,500 or 10,000. I see people say air to water, the time the water spends in the intercooler makes a difference on the amount of heat transferred. Wondering if anyone ever tested the optimal flow rate for max heat dissipation. Well, here's something to think about. You're thinking about it in terms of a radiator, and it doesn't work the same way with an intercooler. The amount of time that, if you could have nothing but cold water, ice cold water passing through there, that's fine. The time that you want heat transfer to take place is going to be decided on by the flow rate of the air, the hot air going through it. You want the thing that's flowing through to be cold, but the time that the air takes to go through there, that's why you're making it big and having lots of surface areas and getting lots of, I doubt that you'd see, if you could have the thing always be 32 degrees, it would cool the best. I'm thinking non-VTEC is better to turbo because less moving parts. What's your opinion? No, that's not accurate. VTEC is way better with turbo stuff because you have more average power production. So when you have more low speed power from a smaller VTEC cam, you have more turbo response. So you have response out of VTEC or out of the VTEC, in the primary cam, and it's really good. I went through this real early on the Honda stuff. Guys are telling me, "Oh no, you can't run them. Can't run them with VTEC. They won't run with VTEC." I'm like, "Why won't they run with VTEC?" Because VTEC. I'm like, yeah, no, I understand. I understand what it does. It's more low speed power and then more top end power. How is that not ideal for a turbo? No, it just doesn't work. I'm like, no, it does. It does work. Trust me. No, we don't do that. We don't do that in the Honda world. I'm like, well, I'm sure you do because lots of people are doing it and you're about to. When running a turbocharged LS on a Terminator X, you have to run an additional map sensor, correct? I'm doing it because I have to buy another map sensor. Doesn't the Terminator X have an internal map sensor? And isn't it a multi-bar map sensor already in there? Embarrassed to say, I really don't know what Vtec is. Vtec is 2 cam profiles, 2 distinct cam profiles, one mild and one much more aggressive, one for more power and one for drivability. And it has the ability to switch between those two at a specific RPM. So it has the ability to switch between those two when the primary cam is done making power and the second cam has started making power. So think about it. Think about having an LS motor and you have a mild stock cam that makes all the power up to 4,000 RPM. And then you have the sloppy stage 2 or whatever that starts making more power from 4,000 to 6,500. So Vtec allows you to have both of those and allows the crossover point to happen right where the bigger cam starts making more power. So it's kind of awesome. Richard, you glossed over the question regarding why someone would want to modify the head to run Vtec all the time. They don't want to run Vtec all the time. They want to run when people do camshafts to get rid of Vtec, and I didn't gloss over it. I covered it thoroughly. When people get rid of Vtec, they do it because they're only running drag race motors with lots and lots of RPM. So all they're running on is the big cam. So they're launching at high RPM and they're only running through the gears at very high RPM. They've got rid of the Vtec mechanism so that they could run lots and lots of RPM. Like I said, 10,000, let's say. Otherwise, if you're concerned about low speed power and top end power, you know, up to 8,500 or 9,000 or whatever, Vtec really is the way to go. Bam, 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 bam. I run an ice box and heat and a 5-gallon pump on my air to water. As long as there's flow, it's transferring lots of heat. It does. We run a 10-gallon cell, like a fuel cell, in the back of the Civic. It's in the trunk, and then we ran 2 transfer pumps that go up into the intercooler, and we run 10 gallons of ice water in it during the run. You have an inactive larger cam lobe at low RPM. That's right. Cords. I can tell you that when I first learned about Vtec, which is obviously a long time ago, but when my buddy Bernie, who is the crew chief for my World Challenge car and stuff, but we were talking about this. He's like, no, he's like, what? Now what happens here? I'm like, yeah, it's got 2 cam lobes and it has a little plunger that's like they send oil pressure to the plunger and it pushes it and locks it over. And we're like, that'll never work. And yes, it does work. It works very, very well. Someday we'll talk about free valve. Yeah, that would be cool. Made 450 on my D series, 16 pounds and 100 shot. Used to buy Vtec controllers to open earlier under boost to get more in. Yeah, there's the boosting a lot of times doesn't change that, because if you have the crossover right for the NA combination, the boosted combination is going to be pretty close. You don't need the bigger cam with boost. You want the thing to make the most average power that it does, and then you want to add boost to that. Have you ever done anything with an old Quad 4? I haven't. I found one in the wrecking yard, which was it was a 442. And I think, I don't know if it was a W41 car, but I've raced those. I've road raced those, but it was it was a Calais or an Olds Achieva. The real W41s are race only and made 1,100 horsepower. That's not accurate. Thinking about a leaf blower to increase exhaust scavenging. I want you to let me know how that works out. When you do more testing on the 8.1, can you test a comp XR270? I've got it, and you're interested. I don't think I have one of those. Will that fit stock piston to valve clearance? Pendant free valve will never go mainstream. I tend to think the same way, but I don't know that we're going to be talking about that. It is cool. It is very cool. I have high compression, K20A2, and now I want to go boost. I should switch out to low compression. Probably so. 12.5 is a lot unless you're running. Even at 12.5, you'd have to run E85 or some kind of race fuel to make that work. It'd be better just to run lower compression. BZ had a pretty wicked high compression D16 non-Vtec drag car. Yeah, he knows how to make power. There's no doubt about that. Replace the overhead cams with solenoids. The problem with solenoids is they usually can't. I think their problem was closing the valves because they tried doing that with Formula One way back. Racer D has a 290 horsepower quad 4 for sale right now. Bad Guys Worldwide is making good numbers with D series. It's possible to make. I mean, if you port the heads, they flow pretty well, and there are cams available for them now. I have an R18. I don't know what an R18 is. I'm not familiar with that. I thought I knew most of the Hondas. Formula One did try pneumatic valves. They also tried electric solenoids and that didn't work. Single overhead cam Vtec is intake only. And on one of the D series, they had triple Vtec on it too. What was that? Right? Or was that it wasn't a B series, right? Man, it's been so long since I've been down this road. 3-stage Vtec. Yes, it was a D series because it had Vtec E also. That's what mine had. Let's see. I want a 5-cylinder Vigor with Vtec. So I'm going ahead and close out our poll. We're ending that at 63% saying no, they have not run boost without tuning. Good for you guys. It's the right way to do it. Vtec is run 2 valves instead of 1. On mine, on my VX, we didn't do that. What it did was it ran very, very mild cam profiles, and also the lobes, the intake lobes were staggered. So it would open the valves at different times, the 2 intake valves, because they were trying to induce swirl so that they could run like 19-to-1 air fuel. I figure with my VTEC, the only route would be a turbo. They do like turbos. I mean, everything likes turbos, and VTEC obviously go together. And on that note, it is time to go. I will see you guys all tomorrow morning. Good stuff happening in the morning for me. It's all good stuff. It's all good. It's all good. Thanks for watching, guys. I will see you all tomorrow.